Okay, in this video I'm going to be covering instantaneous center of zero velocity and the beginnings of motion relative to rotating axes. I'll probably go over more than one video for the second part, so motion relative to rotating axes I'll do in a couple of videos. The first thing to note that when there's a stationary point in relative motion, so if we have, for example, a rotating disc or a rotating wheel even, and it's traveling along a road, a flat road, this is probably not as straight as it could be, but it's traveling along a flat road. This is our center of mass, so we'll say that's G, and this point of contact we will label as C. If we want to consider any point on this rigid body, which the wheel will be, we'll consider this wheel in 2 dimensions to be a rigid body. If we want to consider any point on this rigid body, the instantaneous center of zero velocity is the point about which that point is going to rotate. So if we look at, say, something on the edge of the body here, we draw a line from that point to the instantaneous center, and the point perpendicular, so if the body is traveling in this direction, then the point that's perpendicular is going to be traveling in this direction here. And if the body was traveling in the opposite direction, obviously the velocity would be going in the opposite direction. But for this case, we're going to have positive, so it's going to be traveling towards the right. So the first thing we should do is, well, we'll let that be known as the instantaneous center of zero velocity, or as it's known a lot of the time, it's just IC. We've got to be careful. The IC is merely the point at which there is zero velocity at a given time t. In cases where there is a combination of rotational motion and translational motion, this point is going to change. So if there is rolling without slipping of a wheel, so say the wheel at any point has a combination, so this is a point that it's fixed, has a combination of V everywhere, so it's traveling the same linearly everywhere, and it has the same, and it has a rotational component as well. So there's rotation occurring about this. If we add these two, we end up getting velocity tangential to this point. So perpendicular, if there was an axis of rotation here, it would look something like that. So it's always going to be perpendicular. Alright, so say for example if I've combined those two, we'll end up getting something along the lines of this. If I've combined those two, this has got no velocity. This has got quite a large velocity, and it's traveling in this direction. This has got a smaller velocity, so if we look like so, the velocity up here is going to be proportional because we know that V is equal to omega, which we've done in the rotational component of this section. So omega is the speed at which rotation occurs about this point. So if this is our distance r, it's going to occur at this magnitude. If this is our distance r, it's going to occur at this magnitude. So if we can draw a line like so, we can kind of find what the velocity would be however large the radius would be. Now that's because there is a relationship between the radial length and the velocity, and also the speed at which, or the angular velocity at which the wheel is going to rotate. If we have something rotating about something, the point that's not at the bottom. So if there's rotation occurring about a point here or so, and this is the fixed point, so if we fix that and there's rotation occurring about this, then this line would end up being here, and there would be rotation in the opposite direction of this part. So I'll draw another I'll draw another wheel in here, and say at a point in time it's fixed to rotate about this point, and we look tangentially, this point here is going to rotate like so. It's going to rotate in that direction, this direction here, because it's perpendicular. So say the center of mass is traveling like so, in a clockwise direction, such that if we look here and we look at the center of mass, the velocity will be like so.
What do you mean going like what? Where am I going?
So the velocity here will be like this,
I've got to go to bed.
and the velocity there will be 0. So all we have to do really is define what our instantaneous center of 0 velocity is, and we'll be able to